people that don't or haven't made it here. Okay, so let's go over here. So what are we going to be doing today? Well, our goals is that by the end of the day, you can determine what the slope of a line means in a real life problem. And so that problem is going to be the circumference versus density lab. We're going to do that at the end of the hour here. First, we're going to discuss graphing practice 2. If there's time, we'll discuss the slope practice as well. But I don't want to take up too much of your time because I want to give you enough time to work on the circumference versus diameter lab. So what should you be doing? Well, you should open up you should open up graphing practice 2. It says slope practice here, but really we're going to start off with graphing practice 2. So let me just edit that real quick. Okay. Let's try that again. So what should you be doing? Open graphing practice 2 and notability. Again, we're going to take a look at a couple student examples. We're going to follow the same format as yesterday. List the things that the student did right in the chat. Then list the things that the student can do to improve their answers. And lastly, just make corrections to your practice. If you have any questions about any of this, now would be the time to ask. Okay, and so then just to review, what are we looking for in a science answer? It should have the correct number or value, it should have units, and it should show work, right? Those 3 things have to be there. And if you're really on the next level, you're going to write it as a sentence. Okay, so, oh, Ethan Vu is here. Didn't see that before. Okay, you're marked as present, Ethan. You might get a message from the district because I already submitted it, but you're present. Okay, so do we have a volunteer? Someone wants to be the one that gets their assignment critiqued? Remember that if you are the one who volunteered. Who said that?
I did. Hunter.
Hunter. Okay, Hunter's going to be our volunteer. So remember that if you volunteer for this, we're going to tell you exactly what you need to improve. So it's really actually kind of a good idea to volunteer for these things because it's going to let you let us all take an eye at or take a look at your assignment and help you make corrections. It's really supposed to be a positive thing. Okay, so let's go to materials. This was our assignment from Wednesday. As you can see, I haven't graded anyone's yet. I promise you, I know I'm very behind on grading. I promise you, oh, whoops, what am I doing? I will get caught up this weekend. So this is section 5. We want to look at Hunter. Hunter, did you turn yours in?
I think I did.
I don't think I see you here. Yeah, I don't see yours here. Need someone else to volunteer. Or you can submit yours quick, Hunter, if you know where it is. Okay, Julius, you're present. I got you. You'll probably get a message from the district, but you're marked as present. So either submit it, Quick Hunter, or I need someone else to volunteer. Or I can always just pick someone at random. All right, I'm picking someone. We're gonna go with you, Zoe.
Submitted mine just as you said we're picking someone else.
What's that?
I submitted mine just as you said we're picking someone else.
Oh, we're good. Then I'll pick yours. Go back to this section. Hunter. All right, awesome. I like it when people volunteer because I don't want to force anyone to show theirs if they don't want to. But just remember, this is meant to be a positive thing. It's how can we help you? How can we give you feedback on what you're doing well? Okay, so let's start with number 1. Write a sentence that describes the relationship shown in the above graph. So go ahead and let's critique. What did he do well? What could he improve upon? I should see discussion in the chat, folks. Go ahead and type in there. What did he do well with this one? What could he improve upon? And up and to the right. He wrote about the variables. Good. Yeah, so he talked about how tall the tree is or its height and how old the tree is or its age. So that was good. This is a positive graph, meaning the line goes up and to the left. And you said that in the chat you meant up and to the right. And that's true. This is a positive relationship. The graph is going up and to the right. So that's good. I wasn't looking for a lot here. I just wanted you to describe what this graph tells you. And so something like this first sentence is what I'm looking for. The older the tree is, the taller it is. I think that's a great way to describe it. Okay, so based on the graph above, how tall would a 20-year-old redwood tree be? And so let's zoom out a little bit so we can see the graph and your answer. Go like that. Perfect. Okay, so now we can see the graph and your answer. So let's critique this. And again, I just want to quickly go back to this. What should a good answer in science have? It should have the correct number or value, should have units, and it should show work. So let's ask the class. Did he do those 3 things? Did he write the correct number? Did he use units? And did he show work? What do we think? Which of those things, if any, did he do? Did not show work. I don't know if I agree with that. Because 20-year-old redwood tree right here, and then you follow it up. Oh, look, he made a black dot right here. And then if I follow that over, I know that that goes over to 15. So you really don't have to show any more work than that. You could draw lines here and here if you wanted to. If you know how to find the equation of the line, you could find the equation of the line and show work that way. But I'm not looking for a lot of work here. The dot is fine. That's a great way to show work. How about, do we agree with his number, 15? Does that seem like it works? Matthias likes that number. I think I do too. Because look, it was 20 years old. So 20 up to here, and then follow it over here, 15. So, yep, Emily and Ethan like it as well. That's good. All right, and then last up, did he show units? Yeah. Yep, he put down units for meters, right? So that's good. And then the other thing that I like, remember that really great science answers are written in a complete sentence. This is not a complete sentence, but it's the start of one, about 15 meters tall, right? He could have just said 15 meters, but he, added a little bit of extra in there, so that's good. We want to start working to the point where we're writing a complete sentence. So maybe a complete sentence would be like a 20-year-old tree would be 15 meters tall, right? Something like that. Okay. Based on the graph above, about how old would a 28-meter high redwood tree be? And for those of you who have never seen a redwood tree, they are enormous. They get up to like, over 100 feet tall. Okay, so how old would a 28-meter high redwood tree be? So again, I'm just going to kind of go through this one a little bit more quickly. I think this looks good. So 28, we follow it over here, over to the graph, and we see we're going to hit this green point that he made right there. So good job on including the point. That's how you're showing work for this one. And then you follow it down, and yeah, it looks like it's at about 37, somewhere in between 35 and 40 at least. So the number looks good. And then you included units. Our age was measured in years, and so you put down years next to 37. So I like that. So you're showing work, you're including units. That's exactly what we need. Data were taken for various objects. Using these data, create a graph and sketch the best fit line. Be sure to label everything that needs to be labeled. Remember the things that need to be there for a graph. We need to have a graph title. We need to have axis titles. We need to have a scale, and your scale should make it so that you use most of the graph. You need to have a best fit line. You need to plot the data correctly. What do we think? How did Hunter do? Which of those things, if any, are correct? He has a title. I agree. That's a good title. Height in inches. Ooh, what could be better about the title? Let's just take a minute and talk about that real quick. What could be better about the title? Here, maybe if I zoom up like that a little bit, or scroll up like that a little bit, it'll help you see. How are we supposed to write our titles? What versus what? Yeah, it should be switched, right? Yeah, he is using, it's okay that he just used the title from the columns. That's fine. But these should be switched because this is our X variable, height in inches. So we always put our X variable in the left column. We put our Y variable in the right column, right? And we can see that because we also put, this is our Y variable because it's on the Y axis, and this is our X variable because it's on the X axis. So it should always be Y versus X. So we should switch it around. Height in centimeters versus height in inches. It's a good catch there, Selma. It should be switched. Other than that, how about like, did he do a good job on the scale? What do we think? Is that a good scale for a graph? Come on, yes or no in the chat. Is it a good job on the scale? Selma said yes. Let's get a few more answers here. Anton says yes. Ethan, good. Okay, I totally agree. This is a great scale. It goes up by consistent amounts. So this one's counting by 4s. This one's counting by 10s. And we know it's a good scale because when he plotted the data, well, the data pretty much took up the whole graph, right? He's making very good use of his space. So excellent job on your scale hunter. The data points look like they're good, and your best fit line is nice and straight and goes through all the data. So you did a really good job on this. The only thing I would say that really needs improvement is your title. Okay, so from the graph above, about how many centimeters are equivalent to 35 inches? Explain how you know. About 89 centimeters. So he started with 35 inches, which would be about here on the x-axis. Follow it up. You can see that he made a point here. Excellent. That means that you showed your work. And then when we follow it over to here, it looks like it's about 89, a little bit under 90. So that was an excellent job on that one. That looks like a good estimate. You included units in your answer, 89 centimeters. That's good. And you showed your work. So that's everything that I'm looking for. And mine is going to zoom out a little bit so we can see the next question. So number 6, from the graph above, how many inches are equivalent to 35 centimeters? So now we're going to start with 35 centimeters. So you estimated that about right here. And then you're going to follow that down to the x-axis. It looks like about here, and you said that was about 14. So that looks like a pretty good estimate to me. I like that you included units, inches, and I like that you showed your work. So that's good. Oh, and then number 7, it looks like you missed that one. Write a sentence that describes the relationship shown in the above graph. So what do we think? What's something we could say for the relationship in the above graph? This one's maybe a little bit of a tougher one. What do you think? What can we say? How is the height in inches? So when you're writing these ones, when you're describing a relationship, you should use the names of your variables. So in your sentence, you should use height in inches and height in centimeters. So how is the height in inches related to the height in centimeters? What could we say about those two? Hunter, do you want to take a stab at this one since this is your assignment? What do you think? How is the height in inches related to the height in centimeters? How many inches equal to how many centimeters? Great. That's a pretty good sentence. So you could say how many inches are equal to how many centimeters. That's a great one, Selma. You could also maybe talk about you could maybe like describe like how they are related. So like you could say like your height in inches or your height in centimeters is about 2.5 times your height in inches, something like that. Yeah, percentage of an inch in a centimeter. Good, that's a good one. So you want to turn it into a sentence though, Matthias. So maybe you could say this graph shows the percentage of an inch in a centimeter. That's a good start to a sentence though. Okay, does anybody have any questions on this assignment? If you do, type it in the chat right now or unmute your mic. If you have any questions. Okay. So then for the rest of the hour here, so we are not going to do the discuss slope practice because I want to honor your time and I want to give you enough time to do the circumference versus diameter lab. So if you go to Schoology, and so then if you take a look in my day 5 folder, there's a lesson. It's a circumference versus diameter lab. And so you want to watch that. It's only about 5 minutes. It's pretty short. And then there's an assignment. So quickly, let's kind of talk about what we're going to be doing in this assignment real quick. Whoops. All right. So the purpose of this activity is to determine the relationship between circumference and diameter. So you're going to be taking circles in your house and you're going to be measuring the circumference and diameter of those circles. We're going to make that into a table, and then you're going to plot your table onto a graph, and then we're going to try to use that to determine what the relationship is between circumference and diameter. So for those of you that don't know, I just want to show you real quick. I'm going to stop sharing for a second here. And I'm going to open up my video. Okay, so for those of you that don't know, when we're talking about circumference, we're talking about the distance. I want to hold this where you can see it. We're talking about the distance all the way around. So circumference is the distance around the circle. And that's always going to be longer than the diameter, which is the distance across the circle. Right? So circumference is the distance around. Diameter is the distance across. And so then what you're going to be doing is taking objects in your house and measuring their circumference and diameter. How are you going to do that? Well, you're going to need some things. You're going to need a ruler. Oh, here, let me go back to sharing screen. Sorry. Okay, so what things are you going to need? You're going to need a ruler. Graph paper you don't need. That's going to be on the assignment. You're going to need 4 objects that are shaped like a circle. So that's what cylindrical means. Means there's going to be like a circle shape in them. And you're going to need some string. So some ideas of objects that you could use. You could use like a bottle cap. You could use a plate. You could use a bowl. You could use, what other ideas do you have? What other object could you measure in your house? Go ahead and type it into the chat. What other things could you use to find the circumference and diameter? Clocks, good. Anton said a clock. That's a great example. Anybody else got one? Glass cup, great. Can, cup. Oh, you guys have awesome ideas. Yes, those are all good things that you could use to measure the circumference of. So how does the procedure work? I show the procedure in the video, but I just want to talk about it real quick. So you're going to find a circular object from your house. Then you're going to record the name in the data table. So there's a data table with the assignment. You're going to measure the diameter using a ruler and record it in the table. So the diameter, remember, that's the distance across. Then you're going to take your string, wrap it around the object, marking the spot where the string overlaps with your finger. And then you're going to stretch the string out and measure that with your measuring unit. Julius said cylinder. Good. That's a good one. So you're going to need to probably maybe the toughest thing to find for this is a ruler or a tape measure or a meter stick. Ask your parents where you can find that. You've got all weekend to do it. If you can't find it, go to the dollar store and get a tape measure. They have them there, I promise. Or a ruler. They will have that as well. Okay. And so watch the video because I show you how to do it, and I actually give you your first data point for your for the for this assignment. I measure a roll of tape. If you have any questions, now would be a good time to ask. Yeah, otherwise that's all I got for you for today. So if you have any questions about what you should be doing, go ahead and ask them in the chat right now. Hamza, I'm going to work with you in just a second here. Okay. Yep. You just stick around, Hamza. I'll get you going.
Will you be explaining the slope practice tomorrow?
On Monday? Yeah, we will probably go over the slope practice and this lab on Monday.
Sounds good.
Okay, Hamza, let's get you started then. Yep, so Ethan, I did post that WebEx on Schoology. I meant to tell the rest of the class. Oh, I should stop recording this.